All right, if you would go ahead and have ACT set 5 out. You do that for homework along with reading over pages 70 to 72. We'll get to the material you read over here in just a little bit, but for now, let's take a look at the ACT set. And starting with number 49, Ms. Hernandez began her math class saying, I'm thinking of 5 numbers such that their mean is equal to their median. Okay, what in the world do those numbers mean? Let's refresh from Algebra 2 and pre-algebra. What is a mean?
Average.
It's the average, okay? So you add up all the numbers, you get an average. What's a median? It's the middle number when you do what with the numbers?
Go in order.
Put them in order, you rank them. So the numbers she's thinking of are 14, 8, 16, and another 14, right? And then there's a 5th number. Well, where could the 5th number be? The 5th number could be here, or it could be here, or it could be here, or it could be here. There's a lot of places to put the 5th number. Well, let's just suppose we put it right here. We'll put an X. What's the median?
14.
14. Let's suppose you put the 5th number here. What's the median? 14. Let's suppose you put the median here. Or the number here. What's the median? 14. Let's suppose you put the number here. What's the median?
14.
You realize any way you slice it, the median is going to be 14, right? That's the key to the entire problem. If the median must be 14, then what's the mean? Class? 14. She says the mean's going to equal the median, right? And we know the mean is the average of how many numbers? 5. If 14 is the average, what is the sum of the 5 numbers?
Seventy.
70, right? Therefore, the sum must equal 70. They've got to add up to 70, so when you divide the sum by 5, you get 14, right? So, what's the sum so far on your calculator? 8, 14, 14, and 16 so far adds up to
54.
52.
52. So if they all have to add up to 70, what's the missing number going to have to be?
60.
18. So the 52 and 18 will make 70. And that's the answer, letter E. How many thought all the way through it? Great job. Okay, questions on it now. Again, pre-algebra ideas, but with a deeper level of thinking. Does that make sense? Again, taking that logical thought. Number 50 goes back to something we talked about in Algebra 2. We've got a hyperbola, which you remember is that rational function. We have this asymptote here, so the graph is shifted over a little bit. We have another asymptote, technically, here at the x-axis. And this is h of x. But what would be negative h of x? Do you remember what a negative does to a graph?
Flips it.
It flips it. So that this, if you were to flip it, would look like that. And this, if you were to flip it, would look like that. Which graph looks like that, class? Letter F. Letter F would be the flipped graph. So letter F is our answer. Questions on number 50. Now, if you didn't remember that, here's the other way you could think of it. If you were to plug in the same x value as before, because of the negative there, the y would come out negative, right? So the same x is going to have the negative y value. So instead of right here, it'd have to be down here. Does that make sense? So that's how you could figure out that it flips, right? If you didn't remember that negatives flip the function. Number 51 says each of the variables, t, w, x, y, z, represents a different real number. Given these equations, which of the 4 variables necessarily has the greatest value? Well, if t is equal to all these different things, which letter must be the biggest? Class? Z. Because t is equal to only 0.23 of z, or 23 hundredths of z. Well, it's equal to 1 and 23 hundredths of w. So if you can multiply by that tiny of a number and still get the same thing, z must be pretty big. So z is the correct answer. Anyone perfect on the first page? Question was 2 out of 3? 1 out of 3? All right. Do we understand the 1 or ones we missed now? All right, next one. Oh, statements, reasons. This is a proof. Geometry class. Oh, I've missed you. I'm actually not teaching geometry this year. It's hard on me. It's my first year of not teaching geometry. We're alternating Algebra 2 and geometry, and so last year I didn't teach Algebra 2. This year I'm not teaching geometry.
So people on 11th may learn Algebra 2 instead of geometry now.
Yeah, the juniors this year are taking Algebra 2.
Bro.
I do have a geometry student. She's doing the homeschooling, so I'm grading geometry stuff still, but I'm not teaching.
So you're not completely like
not completely deprived. So here they've got the proof all done, but the steps are all out of order. So all they ask is, what step should we put these things in? And how would we rearrange the order here? Well, we start by saying that a midpoint, definition of a midpoint, right, divides into two congruent segments. Does anything need to be stated before we make that first statement? If a midpoint is in the given, do we need to say anything before we say? No. I mean, other than the given information, right? But after the given, no. So number one can roll, which, notice, all of them have number one as the first statement, so that's not an issue. The question is, where do we go next? Is statement 2 okay to say next? Could we say that EGF and IGH are congruent because vertical angles are congruent?
Yes. We have to say that they're congruent.
Or should we first say, number 4, that they're vertical angles before we say that they're congruent? Yeah, now in our case, we just said, hey, we see the vertical angles, we could go straight to them being equal, but if you're going to take the time to state that these are vertical, then you better go ahead and say that before you say they're congruent, so 4 better come before 2. Oh, well, that settles it right there. It's got to be letter D. Yep, so that kind of narrowed itself down pretty quickly, right? Number 53. Hey, this is what we're going to do today. This is great. So we've got h of x. This is perfect lead, and this is part of today's lesson. So we'll see what we remember from Algebra 2, and then if you're like, I don't remember that, that's fine, because I'm going to review it today, so you're going to have it before you take the ACT. It says, what is g of h of 2? So quick refresher from Algebra 2. We're going to start by finding h of 2. Always go with the inside set of parentheses most. Well, what is h of 2? Remember, that means you're going to put a 2 where the x is and cube it to get, and you're going to put a 2 where the x is and add it to get 10. So h of 2 is 10. So really it's saying find g of 10. Well, that means we need to find g of 10, which means we put a 10 where the x is. 2 times 10 plus 3 is 23. How many had letter K? Letter K. So Chris remembered, back to Algebra 2. The rest of us are going to benefit from the lesson today in pre-cal.
It's really just multiple guess.
Oh, never mind. All right, so all of us are going to benefit from the review we're going to get today in pre-calculus. Number 54. Each side of a smaller square, the white one, is x. Each side of the larger square is c. The area of the larger square is how many square inches greater than the area of the smaller square. Well, anytime it says how much more or how many greater, that means we're going to have to subtract, right? Take the area of the big minus the area of the small. Well, the area of the big, let's start there. It says each side is c longer than a side of the smaller, right? So how long is this baseline on the square? X plus c, or c plus x, correct? And this side is also x plus c, right? And then this side, you don't see the x and the c, but you know it's x plus c because it's a square, and this is x plus c. So what's the area of the large square?
X plus c squared.
Side squared, right? Area of the square is side squared. So x plus c squared is the area of the larger square. What's the area of the smaller square?
X squared.
Each side is x, so it's obviously x squared. So we just subtract. But we do need to simplify just a little bit, don't we? How do I square a binomial? Square the first, square the last, multiply and double. So we square the first, we square the last, and we always get a positive when we square, and then we multiply and double. 1 times 1, doubled, keep the positive, keep the c, keep the x, minus x squared. Well, now I have an x squared and a negative x squared, and so what's my answer?
2x plus
Letter E, 2xc plus c squared. All right, does that make sense now in 54? All right, anybody get that answer? Does it make sense how to think that through? Mainly actually algebra, less geometry, though side squared, you had to remember that, but more than that, it is some algebra in there. All right, number 55. We got this string, we got points A and B and C, and looks like B to C is 18 something, 18 meters, And we got a 60-degree angle at C, a 45-degree angle at B, and it asks how long is it from A to B. You see a little question mark. So I'm kind of going off a little sketchy thing they gave us here. All right, they give us something called the law of sines. You haven't seen it yet, but it's actually coming up in physics in, I think, about a week and a half. You're going to learn this in physics, but they gave you the formula. And the formula is that the sine of P over P equals the sine of angle Q over Q equals the sine of R over R. So let's start with the formula they gave us. The only side I actually know is which side, class?
BC.
BC, which we could call A. Oh, okay, I see. So they're saying for PQR, this would be the formula. Well, I don't have a PQR. What's my triangle?
ABC.
ABC. So instead of P, I've got A. Instead of Q, I've got B. And instead of R, I've got C. Make sense? Okay. All right, so I know side A is 18, right? I know angle C is 60 degrees. I know angle B is 45 degrees. And I'm looking for the side across from angle C. So I'm looking for side C. That's what I want to know. And the problem is, I don't have any complete ratios here, do I? But I know two angles of a triangle. So, and?
180 in a triangle, so just add those two and subtract from 180.
So how big is angle A? Or, yeah, in this case?
75.
75 degrees. Ah, do you see that this is one whole ratio, and this ratio has an unknown in it? I'm going to kind of ignore the middle here, kind of like we did in geometry. Remember where we said we've got these parallel lines, and we got the couple transversal, and we said A is to B, is C is to D, is E is to F, is G is to A, and so forth. And I said, ignore a ratio that's missing something and just go with the whole ratio and the partial in a proportion. Well, now we can cross multiply. C times the sine of 75 degrees, there's the product of the extremes, equals 18 times the sine of 60 degrees. On your calculator, plug it in. Actually, we don't need to, because to get C by itself, what do I have to do? Divide away the sine of 75 from both sides, and they didn't require a calculator. There it is, letter K. No calculator even needed.
Oh, okay. I get it now.
Right, now again, once you learn this in physics, which again, in just a week or two, so before the ACT, you're gonna have this down, you won't bat an eye at this problem. But having not seen this before, I could understand it throwing you off. Does it make a little bit of sense now? It'll make a lot of sense in a couple weeks. Number 56, I really like this problem. We've got a cube with 1/2-inch edges. And the question is, what's the length of a diagonal that runs from one corner of the cube to the opposite corner? So let me see if I can try to draw the same cube they've got here and help you see what they're talking about. So we've got this top cube on the left, top front, corner, and we want the opposite back corner. So it's going to go all the way through the middle of the cube. Does that make sense? Now, if I kind of complete the cube here, we see that there's a square on the bottom as well, correct? What if I, instead of going top to bottom, I went across the bottom? So from one bottom corner to the opposite bottom corner. That's something I can calculate, because I know there's a right angle here, and I know that this angle and this angle would have to be equal by that diagonal, wouldn't they? Which means it's kind of distorted, but what shape do I have here at the bottom? 45, 45, 90, right? And if we call this x and this x, then this would be x squared of 2. But it's a half and a half, so this line right here would be half of square root of 2, right? X squared of 2, half squared of 2. I also know that this line that goes from this bottom corner to this top corner is a half, correct? So if I go from this corner down to that corner, I've got a right triangle because the edge is perpendicular to this line. So then, if I've got a right triangle that has a line of half squared of 2 and a line of half, how do I find the hypotenuse? Pythagorean theorem. So I would say that hypotenuse squared is equal to half squared plus square root of 2 over 2. squared, right? A half squared,
1/4.
1/4. Square root of 2 over 2 squared, 2/4. So h squared is equal to 1/4 plus 2/4 is 3/4. And then you take the square root of both sides, and h is equal to the square root of 3 over the square root of 4, which is 2. And so there's our answer, letter E. All of that, can you see it, is kind of what it comes down to. How many were able to see all of that? The key is you've got to make a triangle, right? How do you make a triangle with a line that goes at this weird angle? Because it's not to any side. You make that line and that finishes the triangle. Questions on number 56? That's just a really fun problem. Number 57, which of the following is equivalent to sine theta times cosecant negative theta? Remember, sine and cosecant negative theta is undefined. All right, what's true of sine and cosecant, class?
They're co-functions.
They are not
They're
cofunctions.
not co-functions. There's like not co-functions. They're opposite.
They're
Reciprocal functions. What's true anytime you multiply a thing by its reciprocal?
0, 1.
you get one.
You always get 1 because things are always going to cancel. You multiply by a reciprocal, you always get 1. But the angle for cosecant is negative. So let's suppose sine's angle goes like this. Sine's going to be positive. But if cosecant's angle goes like this, that's in the fourth quadrant, cosecant's going to be negative. So we have canceling, but one's positive and one's negative, so we don't get 1 but negative 1. But what if the angle goes into the second quadrant? Now sine's positive still. Well, a negative angle, same amount, would go into the third quadrant. Cosecant's negative. So we still get negative 1. What if we go with a third quadrant angle for sine? Now sine's negative, but third quadrant negative would be quadrant 2 for cosecant, right? So no matter what angle you go with, they're always going to be opposite signs, so it's always going to be negative 1, letter F. Does that make sense? And pulling the reciprocal idea. You should have known it had to be either 1 or negative 1. Well, because the signs are different on the angle, negative 1. Questions? All right, number 58. This is just pure algebra 1 and algebra 2. Which of the following is equivalent to that plus that? You can't add without a common denominator. And remember we said for polynomials, you always either factor or group them. Does that sound vaguely familiar? Polynomial, factor, or group. That doesn't apply to the first fraction, but it does apply to the second. And remember I'd say we draw a long fraction bar and everything needs to be represented. The k needs to be represented. The k plus 5 needs to be represented, and there's your LCD. Well, that kind of narrows it down a little bit, doesn't it? To B, C, or E. Right? You can rule out A and D just by knowing what the common denominator is. What do I have to do to top and bottom, though, to go from a k to a k plus 5?
Let's try k plus 5.
Right. And what does that give me in my numerator? 5k plus 25. To go from a k plus 5 to a k plus 5, what do I have to do?
Multiply by k.
Multiply by k. And what does that give me for my numerator?
K squared plus 3k.
K squared plus 3k. So what's my numerator going to need to be? K squared plus 8k plus 25, which means my answer is letter E. Again, that's something, back to my Algebra 2 students tomorrow, we're going to take a test in which a problem similar to that, a couple of problems similar to that, are on the test. Okay, so again, it's just, do you remember this from Algebra 1 and Algebra 2? Questions 58. And that's it. All right, I forgot it only goes up to 58, not to 60. All right, questions on that? All right, going to set that aside if you would, please. And let's go ahead and review some things that we talked about in our lesson yesterday. We talked about a circle, but I called it by a surname. I called it the blank circle. What was that term, class? The unit circle. What was it, class? Unit circle. I call it a unit circle because of the radius. What is the radius?
1.
Always exactly 1 unit. And I said if we draw some triangles on or in the circle, the lengths of those lines relative to a radius of 1 would tell us our various trig functions. We had one triangle that ends up inside the circle. What 2 trig functions are on the inside triangle, class? Sine and cosine. So if I call the center of the circle O, I call this point A and maybe this point B, what line is the sine line? AB. The straight up and down line is my sine line. Think of a sine. If it's laying flat on the ground, you can't read it, right? Ever driven by a stop sign or something got flattened because somebody didn't stop? Okay? The sine line, gotta be straight up and down. What about the cosine line?
OA.
That's OA. So OA is the cosine, AB is the sine. You knew it's not OB because OB is the radius, which is 1, and the radius is never one of the lines, right? Then there was a triangle I drew outside, like this. And let's call this point C, and let's call this point D. Which two functions are in the big outside triangle here?
Tangent and secant.
Tangent and secant go together. Which line is the tangent line?
CD.
CD, the one that's tangent to the circle, right? Which one's the secant?
OC.
OC is the secant line. It can't be OD because that's a radius and the radius is 1. And then if I were to come off the top and come over here to a point E, and let's call this point F, I now form a little triangle off to the side, but what's interesting is the angle is still here. The angle is not actually inside. Now, you could argue there's the angle up here as well. It's true, but this is the angle I'm focused on. Which two functions are in that triangle? Cotangent, cosecant. Which one is cosecant?
OE.
OE, the hypotenuse. Which one's the cotangent?
FE.
FE. Remember, not OF, that's the radius, that's 1. So we said that if I wanted to find a trig function of any angle, I could do so by just looking at line diagrams. So if I had, for instance, a 30-degree angle, how big is the sine, class?
No, one half.
A half, right? How big is the cosine line?
Square root of 3 over 2.
Square root of 3 over 2. If I were to go out just a little further, I'd be able to hit the tangent line. How long is the tangent line?
Square root of 3 over 2.
Square root of 2.
Square root of 3 over 3. Okay, we need to remember that little line. It's just a little bigger than the half. Square root of 3 over 3 is a little bigger. So what is the secant line?
2 times square root of 3.
2 times square root of 3 over 3. It's double, right? And then if I were to draw the cotangent line out here, okay? How big, first of all, though, is the cosecant line?
2.
2. So how big is the tangent line, or cotangent line? You have 2, 1, what goes with it?
3.
Square root of 3, right? And also, it's really big, right? Square root of 3 is almost 2, right? Square root of 4 would be 2. This is almost 2. It's almost really big, right? So maybe that'll help you remember that. I think, let's go with the 60-degree angle next. How big is the cosine line?
1/2.
Clearly a half. Then how big is the sine line?
Square root of 3. 2.
Square root of 3 is really big.
Oh, square root of 3 over 2.
Square root of 3 over 2, right? It's just a little bit smaller than the full 1 length. What if I were to extend the tangent line up here? How big is the tangent line?
Square root of 3 over 3. Square root of 3.
Square root of 3. How big is the secant line? 2.
Yeah.
2 radii. How about the cotangent line?
1.
Here's the half. It's a little bigger than the half.
Square root of 3 over 2.
Square root of 3 over 3 is a little bit, that's the one you just got to memorize. So how big is the cosecant line? 2 square root of 3 over 3. It's double it, right? It's always going to be double that length in the 30, 60, 90. Let's go to the 45, 45, 90 with a 45-degree angle. It's not almost 1. Actually, my 45 is a little off there, but, you know, just a tiny bit. It's not almost 1, but it's definitely not even close to a half. It's definitely bigger than a half. It's kind of in between a half and 1. How big is this line for the cosine?
Square root of 3 over 2.
No, square root of 3 over 2 is
yeah.
almost 1. This isn't quite that big. It's not as big as square root of 3 over 2, which would be about here. So it's square root of 2 over 2. How about the sine line? Well, it's got to be the same thing, right?
Yeah.
45-degree angle, so it's also square root of 2 over 2. What if I were to extend the tangent line up here? Just looking at the picture. How big is the tangent?
No.
It's the same length as the radius, right? If it's a perfectly drawn 45, so how big's the tangent? 1. How big then, if we got a 1 here, of course we already know we got a 1 here, how big's the secant? 1, square root of 2. How big is the cotangent?
1.
Also 1. So how big is the cosecant? Also the square root of 2, right? So a lot of matches in this one. What about at a 0 degree angle? How big is the tangent line? 0. What about the sine line? 0. What about the cosine line? 1. What about, remember the tangent goes up and then comes over. What about the secant line that came over? 1. What about the cotangent line?
0. Or undefined.
Undefined. What about the cosecant line? Also undefined. What about at 90 degrees? We have a 90 degree angle. How big is the cosine line? 0. What about the sine line?
1.
What about the tangent line?
Undefined.
What about the secant line?
Undefined.
What about the cotangent line?
0.
What about the cosecant line?
1.
Again, to me, the quadrantal is the biggest benefit. But again, part of it's kind of seeing the progression. Watch again the sine. Sine is nothing. Sine's a half. Square root of 2 over 2. Square root of 3 over 2. 1. Look at the cosine. 1. Square root of 3 over 2. Square root of 2 over 2. Half. 0. Look at the tangent. 0. Square root of 3 over 3. 1. Square root of 3. Undefined. Along with it, the secant line. 1. 2 square root of 3 over 3. Square root of 2, right? 1, 1 square root of 2. 2, it's double, and then undefined. Same thing's going to be true with the cotangent line, but I'm going to start on a different circle here. Cotangent's undefined at 0, so is cosecant. At 30 degrees, square root of 3. 45 degrees, it's 1. 60 degrees, it's just bigger than a half, square root of 3 over 3. And then 90, it's 0. The cosecant is undefined at 0, 2, square root of 2 with the 1, 1. 2 square root of 3 over 3, 1. Kind of see the progression of the lines. Of course, we'd have to apply ASTC if the angles weren't in the first quadrant. Let's go and move on, though. After that quick refresher, we'll kind of see that again off and on at various times here. But again, the triangles are available too if you need them. Next section, your notes. Function notation. Function notation. You know, we talked about this extensively in Algebra 2. In fact, we had a whole test that was nothing but functions. Function notation. It's just another way of writing equations, but it's a more concise mathematical way. For instance, if I said y is equal to 3x plus 2, if x equals 2, then y equals what?
8.
Class?
8. Wait.
Oh, yeah, I'm sorry. 8, okay. Oh, I was just seeing if you were confident in your answer. Well, a better way of saying this, instead of saying y, we could say f of x equals 3x plus 2. And then instead of saying if x equals 2, y equals what, I could say f of 2 equals what? And the answer would still be 8. Because we're simply saying that the x is now a 2. And we replace the x with a 2. And we get 8. What about f of 4? What would be f of 4, class?
14.
14, because we now replace the x with a 4. And we get 14. Remember talking about function notation. What if this had been a negative 4?
Negative 10. No, 14. 10. 12.
Negative 10. This gives negative 12 plus 2 would be negative 10. All right, write this on your paper if you would, please. We can use f of x, we usually do, but remember there were other letters. G and h are often used as well. Suppose g of x is 5x squared, negative 7. I want you to find g of 3 and g of negative 1. At your seats. Find g of 3 and g of negative 1. You are allowed to use your calculators if you need to. What do we get for g of 3, class? 38. We'll start by putting the 3 here, squaring it to get 9 times 5 is 45, minus 7 is 38. What about g of negative 1?
Negative 2.
Negative 2. We'll square the negative 1 to get 1 times 5 is 5, minus 7 is negative 2. How many of both of those correct? Questions? Write this one down. F of x equals x plus 7. I want you to find f of negative 1. All right, what'd you get?
6.
6, yeah, super easy, right? What if I said find f of a squared? Well, what did I do with the -1 class? Plugged it in for x. What should I do with the a squared? Plug it in for x. What do I get?
A squared plus 7.
A squared plus 7. Can't do anything with it, but there we go. All right, so how about this one? What about f of b minus 3? What do we get, class?
B plus 4.
b minus 3 plus 7, or b plus 4. Does it make sense how we can plug variables or even polynomials in place of the x? Write this one down. H of x equals x squared minus 3x. I want you to find h of 0, h of 4, h of 1, and h of m cubed. And Ethan, h of 0.
0.
0. You have to plug a 0 in for both spots. 0 squared is 0, obviously -3 times 0 is 0. What about h of 4, Jamie?
4.
4. 4 squared is 16. 3 times 4 is 12. 16 minus 12 is 4. What about h of 1, Quentin? -2. You're going to square the 1 to get 1, multiply 3 times 1 to get 3. 1 minus 3 is -2. And then the h of m cubed, Chris.
And this is power minus 3 cubed.
There we go. Square it to get m to the 6th, and multiply by -3 to get -3m cubed. How many went 4 for 4? You got them all. Questions? How about this one? G of x is equal to x squared plus 5x minus 4. Want you to find g of 2, g of a, g of b squared, and g of m plus 1. Be sure to simplify as much as you possibly can in each case. All right, what'd you get for g of 2, Chris?
G of 2, I got 10.
10. Let's square the 2 to get 4, multiply 5 times 2 to get 10, and then subtract the 4 back away to end up with 10. What about g of a? What did you get, Quentin?
A squared plus 5a minus 4.
There we go. We just replace all the x's with a's. Pretty easy. What about g of b squared? Jamie?
B is the 4th power plus 5b squared minus 4.
There we go. Again, just replacing the x's with b squares. And then what about g of m plus 1? Initially, Ethan, what do we get when we just plug it in?
N plus 1 squared plus 5 times m plus 1 minus 4.
There we go. But we're not going to leave it like this because I know how to square a binomial.
Square last, multiply double.
To get?
M squared, 1.
Multiply 1m, double it to get
M squared.
2m. Remember when you double something, just times 2. So 1m doubles to 2m. And then of course with the 5, I'm going to need to
Multiply.
right, distribute is the term for it, but distribute to get.
Plus 5m. Plus 5.
And of course we have the negative 4 here. I can combine the m's together to get m squared, then 7m, and then all the constants can combine to get positive 2. And there's my answer. How many have this simplified answer? For the last one.
But I was thinking like a squared plus 5a minus 4. You guys would,
No, that's all you can do, right? Here's one that is, again, all of this is stuff we did in Algebra 2. Here's one that I don't think we did in Algebra 2. What about a function involving 2 variables? F of xy is x squared plus 3xy minus y squared. What if I said find f of 3, 2? What do you think we ought to do here, Jamie?
Plug in the numbers, or like put 3 reverse x and 2 reverse y.
Good, the 3 goes in for the x and the 2 goes in for the y. So this becomes 3 squared, class,
9.
plus 3 times 3 times 2,
Well,
18, minus 2 squared, 4. And then 9 plus 18 minus 4 equals 23. So what about if I gave you f of -1, 5 at your seats? F of -1, 5 at your seats. Wake up, Chris. What you got? Gotta get more sleep tonight, man.
I'm getting so much
What'd you get? It might help if you work it on paper. Don't always have to do it on paper. If people can do it in their heads. Quentin worked it on paper, though. What'd you get, Quentin?
Negative 39.
-39 is correct. How many had that? All right, so careful here. When you square the -1, it becomes the +1. And then 3 times -1 times 5 is -15, then minus the 25. That gives you the -39. How about this one? What if I gave you f of a plus 2? You're definitely going to have to work this one out on paper at your seats. F of a plus 2. Sense now what you should have done. You remember to change that to a negative and that to a negative, but you forgot to change that to a negative. And 2a and 4a would have given you 6a anyway, not 4a. So a little something-ish there. You forgot to distribute the 3 with the 2. You did the a times the 2, not the 3a times the 2. Again, first step, especially when we're working with variables, just plug it in, right? The a is squared. It's a 3a plus 2 minus a plus 2 squared, right? And distribute the 3a, as I was just mentioning to Jamie there. Careful with that. And then here's where the fun part is. you've got to square first, then change all the signs. And when you combine, you should get 3a squared plus 2a minus 4. Questions on function notation. Another thing we did, and we looked at this just a moment ago on the ACT prep, is if you have functions of functions. For instance, write this down on your paper. F of x equals 3x minus 4, and g of x equals x squared minus 1. And I can actually take a function of a function. But remember, we always work inside out, starting with the innermost set, simplify, and work our way to the outermost set. So, for instance, if I said I want to find g of f of 2, I need to start class by finding f of 2. So what is f of 2, class? 2. So this then becomes g of 2, because that's what f of 2 equals. What is g of 2, class? 3. And there's our answer. Same kind of thing as what we would have had to do on the ACT prep. What if I said I want you to find f of g of 3? We're going to start class by finding g of 3. What is g of 3? 8. So I'm going to find f of 8, because 8 replaces g of 3. What's f of 8? 20. And there we go. Make sense? What if we had this one? F of g of f of 4. F of g of f of 4. Well, we're going to have to start by finding... Ooh, boy, this is going to get big really quick. Tell you what, let's change it instead of 4. Let's go with something small. Let's try negative 1, maybe? I don't know. Let's see if that's any better. Let's try f of negative 1. What's f of negative 1? I don't know if that's any better. All right, so here we go. So this becomes f of g of negative 7 instead of f of negative 1. Okay, what's g of negative 7? 48. So then this becomes f of 48. Really trying to do it without the calculator here. Jamie breaks down and punches them in.
140.
140. Hey, he did it without the calculator too. 140. Hey, do we see how to work with functions of functions? Okay, questions on this? Again, we had a little trouble with it on the ACT prep a few moments ago. I refreshed memory there. Do we feel like we've got it now? Any questions? Turn in your textbooks then, if you would please, to page 72. Page 72. And I want you to do 1 through 4 and 6. Page 72, numbers 1 through 4 and 6. are you supposed to do with any other function notation? Wherever you see the thing in the parentheses, you put it wherever it says x, right? So what would f of 30 be if we wrote it out? Sine of 30. And what is the sine of 30 degrees? I'm not asking for the radian. What is the actual sine of 30? Special angle, special triangle, or line diagram if you happen to have that mastered already. But that's what we're doing. And then number 6, we just plug in the following. Alright, for sake of time, pencils down. Look up this way. For the first one, what did you get for f of 2, Chris?
9.
9. F of 3, Quentin.
14.
F of A, Jamie.
A squared plus 5.
And f of h minus 1, Ethan.
A squared plus 2h plus 4.
Well, on the multiply and double, make sure we keep the sign, so negative 2h, but otherwise, and then it's a plus 1, plus 5 more, so plus 6. So again, h squared negative 2h plus 1 plus 5. Does that make sense? Square the first, h squared, square the last, positive 1, multiplies negative 1h doubled is negative 2h, and then tack on the 5. Make sense? All right, what about for the next one, f of 2? Let's go back to Ethan for redemption.
F of 2.
Mhm.
I got 4.
All right, so 2 squared
4.
plus 2
6.
minus 6.
0.
Should be 0
I think I did.
for that one.
I think I minus 2.
Okay. What about f of 0, Jamie?
Negative 6.
Negative 6. What about f of negative 2, Quentin?
Negative 4.
Negative 4. And then we've got f of h squared minus f of 0. Well, what would f of h squared be, Chris?
F of h squared would be h plus h to the 4th power plus h squared minus 6h.
Where'd you get the h from? Just minus 6, right? There's not a y to plug anything in for, so you square the h squared, you put the h squared, and there's no h squared put, so just negative 6. And then we've got to subtract f of 0. Well, what is f of 0? We could do that part in our head. Negative 6. But anytime we have to subtract a negative, that's the same as adding a inverse positive, right? And so the positive 6 and negative 6 are just going to cancel. So my answer is just h to the 4th plus h squared. How many have that answer on this one? Questions? Look at the next one, f of xy. And we've got x squared plus y squared. What about f of 2, 3, Chris? 13, stay with me for just a moment. What about f of negative 1, 5, class?
26.
26. And then f of 0, 0?
0.
0. Here, it's a trig function, but you still just plug in whatever it says for x. So we plug in 30. What's the sine of 30, class? A half. What about the sine of 90? 1. What about the sine of 0?
0.
And the sine of 180?
1.
Remember, it's a reference angle of 0. So it's going to be the same thing as f of 0. So 0. Or, again, if you're picturing a unit circle, what's the sine of 30? This is half. 90, it's 1. 0, 0. 180, 0. Right? And I tell you what, we'll make 6 extra credit if you want to take the time to finish it. So number 6, we'll count that as extra credit if you haven't done it, and you can go ahead and finish. If you already did it, then you've already got the extra credit done. So page 72, number 6, extra credit, no homework this evening. Have a wonderful rest of your day.